This is section 12.6, inequalities involving absolute values. Okay, so we've done a little bit of work with absolute values before, where basically if you've got a number inside those absolute value signs, so like the kind of lines that go around a number, so like say absolute value of -4, we know that that's the same as the distance away from 0 on a number line, so -4 is 4 spaces away from 0 on a number line, so it would come out to be 4. So basically, a simple way of thinking about this is it just kind of makes that negative go away. Now, you have to be careful in certain situations because some of them are a little harder than that, but in general, that's kind of what's happening. Okay, so if we were just looking at absolute value of x is equal to 3, basically what we've got here is we've got two options that could be in there for our x. We could have either x is equal to 3, because if we plug 3 in there, that would work, because absolute value of 3 would be 3 away from 0 on a number line. And we could also have -3, because -3, if we take the absolute value of that, that's also 3 spaces away from 0 on a number line. So like we could have a point there and a point there, because that's 3 spaces away, and that's 3 spaces away from 0. Now when we get into dealing with our greater than or less than signs, things kind of change a little bit. Okay, so here we've got less than, so absolute value of x is less than 3. These are similar to the and ones that we did in the last section. If we've got x is, or absolute value of x is greater than 3, these are more similar to the or ones that we did in the previous section. So with this one here, we know we're going to have open circles because there's no line underneath. Open circle there, open circle there. Now, what I need to do here to figure out if I need to shade the middle or going in both directions here is I can plug in numbers here to see if they work. So one thing I could plug in would be 0. So if I take that first one there, absolute value of x is less than 3. If I plug a 0 in there, 0, if I take absolute value of that is less than 3, well, absolute value of 0 is 0, so 0 is less than 3. Is that true? Yeah, it's true. So when I do my shading here, 0 should be included because it worked out. Okay, so I'm going to shade in the middle. Now say I plugged in a number like 4, because if I had a number line here, 4 would be over here, right? So if I did absolute value of 4 is less than 3, well, if I try that, that would be 4 is less than 3. That's not true, right? So it makes sense that that wouldn't be shaded in our graph. Okay, so now doing our OR one here, now we've got absolute value of x is greater than 3. So again, I'm going to do my open circles here on -3 and 3. And then now I'm looking at numbers that are bigger than that when they're in the absolute value. So again, I could use 0. So if I take absolute value of 0, 0 is greater than 3. Well, is that true? No, it's not, so I know I don't need to shade my middle part here, so that's not going to be included. If I plug in a number off to the right, like 4, if I take absolute value of 4, is that greater than 3? Well, yeah, it is, so I would want to shade things off to the right here. Same would work going the other way, because if I plug in like a -4, which would be on this side of the -3, absolute value of -4 is greater than 3. Well, absolute value of -4 is 4. And then we ask ourselves, okay, well, is 4 greater than 3? Yeah, it is. So we shade the outer way there. Okay, so that's kind of how that works. Now, what we're going to have to do with most of these problems is we're going to have to do some solving, okay? So you remember when we've done absolute values before, what we do to make them go away is we split it into two equations, one where we're dealing with a positive and one where we're dealing with the negative. So what we're going to do here, same as what we've done in the past, I'm going to go x plus 3 is less than 4, and that's going to be one of them that I can solve. Now the other one here, I have to deal with a negative, so I'm going to go negative, and then I treat all that stuff that's in parentheses like a chunk. So negative x plus 3 is less than 4. Okay, so I just broke that into two things, one of them being the positive version of it, one of them being the negative version of it, so I get both halves of that, just kind of like I had before with the 3 and the -3. So then I solve this one out here. To get rid of adding 3, I need to subtract 3 from each side. So it would be x is less than 1. And then over here, what you have to do is you have to think about this like distributive. So I can take the negative and distribute to both of those, so negative x, and then the negative times the 3 would either be minus 3 or plus a negative 3. It's less than 4. So then I would get rid of subtracting 3 by adding 3 to each side. So negative x is less than 7. And then to get rid of the negative in front of the x, I would divide by negative 1 on each side. Then in my head I'm thinking, okay, well I divided by a negative there. So I've got to do a sign switch, and then 7 divided by negative 1 would be negative 7. So those would be my two answers there. And then I just graph those, so I would have 1 and negative 7, so negative 7, 0, and 1. With both of them, they're going to be open circles because there's no equal to line underneath. So open circle on 1, open circle on negative 7. With the 1, I've got x is smaller than 1, so I want everything smaller than 1. So going that way with my arrow. This one here, I want x is greater than negative 7, so numbers bigger than negative 7 would be going off to the right. So my arrows are going towards each other, so I'm going to shade the middle there. Okay. Here. So this one I've got absolute value of x minus 7 is less than 4. So again, got to break it into my positive version of it and the negative version. So I'm going to go x minus 7 is less than 4. That's one of them. And then this one's going to be the negative. So negative, and then in my parentheses, my chunk that's in the absolute value. So x minus 7 is less than 4. So then when I solve it there, to get rid of subtracting 7, add 7 to each side. So x is less than 11. It's one of my parts of that. And then with the other one there, I can take my negative and distribute it. So that would be negative x plus 7 is less than 4. So to solve that one, to get rid of adding 7, I would subtract 7 from each side. So then I would have negative x is less than negative 3. And then to get rid of the negative in front of the x, divide by negative 1. And then since I'm dividing by that negative there, sign's got to switch. And then negative 3 divided by negative 1 would be a positive 3. Okay, so those would be my two things there. If you want to with these, you can also rewrite them as one inequality. So like you could put your x in the middle, 3 on one side, 11 on the other side, and go, okay, I want numbers that are smaller than 11, so going that way, and numbers that are bigger than 3, going that way, and that would be the same as those two together. So either those two together or that all as one would be your answers. So then again, we've got to graph these. So put my numbers here, 3, 11. It's going to be open circles for both of them because there's no equal to line underneath. And then I want numbers that are smaller than 11, so going that way. Numbers that are bigger than 3, going that way. So if I do my shading here, I'm going to end up with things that are in the middle. Okay. Alright, next set of them here. I've got absolute value of x, or absolute value of 4x is greater than or equal to 16. Okay, so same situation, break into my 2. So I've got 4x greater than or equal to 16, other one negative, and then whatever's in my absolute value, so x minus 4 greater than or equal to 16. So to get rid of multiplying by 4, divide by 4 on each side. So x is greater than or equal to 16 divided by 4 is 4. So that's one of them. And then the other one here, if I distribute the negative to the 4x, that would be negative 4x greater than or equal to 16. So then to get rid of the negative 4, divide by negative 4 on each side. Then since I'm dividing by a negative there, gotta be a sign switch. That stuff would cancel to be x, and then 16 divided by negative 4 is negative 4. So those are my two answers there. And then when I go to graph this, I would have negative 4, 0, and 4. So these ones are going to be solid or filled in circles here because they're both equal to. And then I want numbers that are greater than or equal to 4. So bigger than 4 would be going that way. Numbers that are less than or equal to negative 4. So going that way. So this time when I do my shading, I'm going to have the middle open on this, and one of them is going to be going off to the right, and one of them will be going off to the left. So you might have some like that as well. Typically your ones that are greater than here are going to be going in opposite directions, and your ones that are less than are going to the middle. That's typically how those work. Okay, one more here like this. So we've got absolute value of x minus 2 is greater than or equal to 3. So again, break into our two parts here. So x minus 2 greater than or equal to 3. Other one, negative, and then our middle chunk there of x minus 2 greater than or equal to 3. So here to get rid of subtracting 2, add 2 to each side. So x is greater than or equal to 3 plus 2 is 5. So that's 1/2 of it. This one, distribute my negative to both of those things, so negative x, and then that would become a positive 2, greater than or equal to 3. To get rid of adding 2, I'm going to subtract 2 from each side. So negative x is greater than or equal to 3 minus 2 is 1. And then to get rid of the negative with the x, divide by negative 1 on each side. So x, sign switch, because I'm dividing by that negative there. And then 1 divided by negative 1 is negative 1. So those are my answers there. And then I go and graph them. So I've got negative 1, put a 0 there, and 5. So numbers that are greater than or equal to 5, so closed circle on 5. And I want anything that's bigger than that, so going off to the right. And then the other one there, x is less than or equal to negative 1, so that would be a closed circle again because it's equal to, and then I want numbers that are smaller than negative 1, so going off to the left there. And again, you would have that opening kind of in the middle there between negative 1 and 5. Okay, so the last stuff here, tolerance, if you ever see that in like a story problem, it's the amount of error or uncertainty that is allowed when making measurements. So a lot of times in factories, when you make something out of like a mold, there's going to be a little bit of an error. You know, it's probably not much of an error, maybe, you know, a 1/16 of an inch or something like that, but more than likely there's at least some error to the actual size. Okay, so what we're going to do here is we're going to use that to figure out what kind of the range of our error can be. And I think it's like a factory problem. So it's on page 532. So what it says when producing 1/2-inch bolts for bicycle parts, the tolerance is 0.005 inch, and it wants us to figure out what is the range of acceptable bolt measurements. So we want to figure out how much above we can be and how much below we can be and still be fine. Okay, so in the end we can be 0.005 away from whatever our measurement is. So that's going to be my number that's going to go off to the side here. And then how this works is you can put these inside absolute values. So like absolute value of whatever your measurement is. So we can just say x in this case, minus your 1/2 inch that your bolt actually is. And since this is an error, we want our error, so this here, this is the error part, we want that to be smaller than 0.005. So when we do this, it's going to be smaller, and then it could also equal that amount, so you can have an equal to sign there. Okay, so then we can break it into our two parts here. So we would have x minus a half is less than or equal to 0.005. And then our other one would be negative x minus a half is less than or equal to 0.005. So then I'm going to treat this, I'm going to change it to a decimal, so half is the same as 0.5. So to get rid of subtracting a half, I'm going to add a half, so I'm going to add 0.5 to each side. Oops. So then that's going to go away, and I would have x is less than or equal to, so that would be 0.505 for that side of it. And then over here, I'm going to distribute that negative to both of those things, so negative x plus a half, I'm going to change it to 0.5 there. It's less than or equal to 0.005. So then to get rid of adding a half, I'm going to subtract a half from each side. So then that would be negative x is less than or equal to, and then that would be negative 0.495. And then from there, to get rid of the negative with the x, divide by negative 1. So x would be sign switch here, greater than or equal to, and then that would end up being positive when I do negative divide by negative. Okay, so those are my two answers here. And if you think about this logically and how I would do it if we weren't thinking about absolute value problems, is I'd think, okay, I've got a half and I can be 0.005 above that, which would be this measurement, or I could also be 0.005 below that, and then anywhere in the middle there, I would be fine. Okay, so when I go to graph here then, I'll have 0.495, and 0.505. Both are going to be filled in circles because it can be equal to on both of them. And then I want numbers that are smaller than the 0.005, so going that way. And numbers that are bigger than the 4.95, so going that way. So numbers in between those would be acceptable for my bolts to pass the requirements to go out to, you know, the consumers or people who are going to buy them. Okay. Alright, so that is it for our notes. So you've got page 533, 16 to 42 even.